Hi everyone, we're going to evaluate the integral analytically from negative pi divided by 4 to pi divided by 4 of hyperbolic cosine of tan of theta times secant squared theta d theta. So let's change this to u substitution. We're going to let u equal tan of u, or tan of theta. So our derivative of u equals secant squared theta d theta. And when we do our u substitution, we're going to have to change our lower and upper limits. So when u is pi divided by 4, or negative pi divided by 4, then that means our tan is going to be, let's just do it this way. So we just plug in tan, a negative pi divided by 4 equals negative 1. So that'll be the lower limit. And tan of pi divided by 4 equals 1. So now I can rewrite my integral as from negative 1 to 1. And we have hyperbolic cosine of u. And this is your u. And this part here is your du. All right, so let's also write this as, when you integrate this, we're going to get hyperbolic sine of u. That's the antiderivative of this. And we're evaluating it from negative 1 to 1. So this is going to be hyperbolic sine of 1 minus hyperbolic sine of negative 1. And what we're going to use is this formula here. So this is going to give me equals e to the first power minus e to the negative 1 power divided by 2 minus e to the first power minus e to the negative first power divided by 2. And this is negative 1. This is going to be plus 1. Sorry. So that's when we plug in our negative 1. Now, simplifying this, we're going to get e minus e to the negative 1 power. This is to the first power. Minus e to the negative first power. Minus e to the first power, all divided by 2. All right, and when you add these up, this is going to end up being a plus here, sorry. So you get 2e minus 2e to the negative 1 divided by 2. And this, if you factor out a 2, you get e minus e to the negative 1 power divided by 2. This cancels out, and we're left with, this is your exact solution, and your approximate solution would be approximately 2.350. Thank you. Have a nice day. Bye-bye.